Hello and welcome to sequencing call number 18, where we're going to talk about Ethereum R1, a new base rollup that was announced just a few days ago. It's been quite a while since we've had a sequencing call, so good to get it back in motion. I'm going to give a very short presentation, and then I'll hand it over to the Ethereum R1 team. Okay, let me share my slides. Okay, so as I said, today's topic is Ethereum R1, and these are the four people who authored the Ethereum Magician's Post: Jajun, Ariel, Junga, and Ahmad. And the main presenter for today, as I understand, is Ariel, but the other co-authors should also be participating in the discussion. Here is a quick overview of the based ecosystem. Basically, what we have here is a few different types of players. We have the early movers that are already based. We have a few up-and-coming rollups that are potentially going to launch as base rollups. And then we have incumbent rollups that are potentially going to migrate from centralized sequencing to base sequencing. And I think what's starting to emerge here as a strategy for these incumbent rollups is to have a two-phase strategy. So phase one is to enable preconfirmations, centralized preconfirmations, to get familiar with the concept and the infrastructure and the integration with the wallets. And once you have these preconfirmations, those are forward compatible with decentralized sequencing, such as base sequencing. So I think projects like Base, for example, have announced that they're going to have 100 millisecond preconfirmations on mainnet very soon. And projects like Inc. And others are probably, in my opinion, going to do a similar thing. And hopefully they love preconfirmations and they will also want decentralized sequencing at some point. And then we have a bunch of other players that are building infrastructure and products and services around base sequencing. And today I just wanted to highlight the two new icons that I've added. The first one is R1, a new base rollup project. And I also wanted to highlight Buildernet as potentially being effectively a gateway in the mental model that we have. So the proposers, the R1 proposers, can basically delegate their sequencing rights to Buildernet, and Buildernet will be able to provide base commitments such as preconfirmations. And I had a call with the Flashbots team a few months ago, and it seemed like we aligned on this vision of Buildernet effectively being a gateway. Now, zooming out, what are we trying to do with these sequencing calls? We're trying to enrich the network effects around Ethereum. And in particular, what we're trying to do is have synchronous composability across the L2, something that we've lost with fragmentation. And the two key ingredients that we need in order to achieve synchronous composability are real-time settlement and shared sequencing. And one of the really exciting things is that we've made tons and tons of progress regarding real-time settlement. So, finally, we're reaching a point where these two ingredients are starting to mature, and we can start to look forward to potentially having synchronous composability once we mix the two ingredients together. So I just wanted to quickly recap the various ways in which we can have real-time settlement. Like traditionally, I've really emphasized SNARKs as a tool to achieve it, but there's multiple other ways to achieve real-time settlement. So SNARKs is number one, and SNARKs are absolutely on fire. There's a lot of effort towards getting real-time proving. Actually, ETH Proofs call number 2 is going to be dedicated to real-time proving, and we're going to have all sorts of announcements related to real-time proving in the weeks and months to come. Another way to have real-time settlement is actually to leverage the L1. There's some efforts to scale the L1. There's potentially a bump to 60 million gas coming soon. But there's also the effort around the execute precompile, which is another way to get real-time settlement, whether or not the execute precompile is enforced by snarks or through naive re-execution. And then there's a couple of other miscellaneous tools that are available. One of them is TEs. And here we, as I understand, there's been some progress on having really ultra low latency TEs. So for example, as I understand, BuilderNet is running builders now, the full stack in TEs with really, really low latency. So that's kind of a good tool to potentially work with. And of course, we can use economic security. We can have, for example, an AVS that allows anyone to place pledges that state transitions are correct. And you can imagine even combining all of these things. So you could have a snark, a TE proof, and some sort of economic proof of, let's say, a million ETH. And these three things combine, all of which in real time should provide plenty of security for settling your rollup. And then there's another tool that is, I guess, less exciting, which is to have some sort of trusted and permissioned committee or even centralized operator who will just sign off on the validity of the state transitions of the L2s. Okay, now if you're interested in learning more about ETH proofs, which is probably like the most exciting development of the last few months, in my opinion, then you're welcome to join the community group. So that's it from me. I will now hand it off to the Ethereum R1 team with Cassandra, who will make a presentation. Cassandra, Ariel, the floor is yours.
Yes, hello. Can you guys hear me? Sorry, I was having an issue with my sound, so you'll hear me from over here. But okay, cool. And then let me see if I can share my screen as well. I believe it's this one. And you guys can see this?
Yes.
Alrighty, so it worked. Hi everybody, I'm Cassandra or KZG.eth or Ari AFK. So great to see you all. And I'm contributing to this Ethereum R1 project. Before we even get into it, we're going to start from the beginning and we will get to sequencing. Actually, a question I have, Justin, is how much time do you want me to take here, just in case, just to know?
So you have the full 50 minutes, and the way that we usually do it is that after the hour, we have unrecorded conversations that won't go on YouTube, and we can be a little bit more candid. So stay around up to an hour and a half, but you have the full 50 minutes for presentation and Q&A.
Perfect. Yeah, I imagine we won't even necessarily take that long, but maybe we will. That gives me plenty of time. So thanks for letting me know. So yeah, one thing I just want to say up front is I think this is a really new project and a different way of approaching these things. So take everything that I say with a grain of salt, because there's no singular leader or founder or person I'm just one of the community members and contributors here. And while we do have this moniker of maybe core contributors, even that we see ourselves as just facilitators of this project and don't want to necessarily be seen as like owners or have the final say. Yeah, just want to mention that. So take everything I say here with a grain of salt, but somebody's got to present R1, and here I am. So really, really excited about this. So this is the Ethereum R1 project. What is it? So
Ariel, would you mind making it full screen, the presentation?
Not at all. Let me go for it. Let me see if it works. Works
nice.
For you guys?
Perfect.
Okay, cool. So what is R1? I think the most important contextual thing to say, in my opinion, is that it's really right now more than anything an idea or an offering. And so I think we're really excited about how this general idea or approach towards layer two and trying to build layer two solutions on top of Ethereum, like how it can mobilize the community and be excited to people. But there are many things that are not yet set. There are a few, and they're named here on our website. You can go to ethereumr1.org or ethereumr1.eth.limo. And I'll just name a few of the core ideas. So it's a new rollup project. It's 100% donation funded. So no auxiliary token, no private investors, just ETH contributed. The ticker is ETH. The goal is to be a stage 2 based rollup from day one and have like a very, long, slow upgrade process, if any at all, and really try to make it so that users have a transparent experience in terms of trust assumptions regarding the Ethereum blockchain. Wanted to have this ethos of being an Ethereum public good. Some base fees may go to R&D, but there's a commitment already that by 2030 everything will be burned and nothing will go towards R&D anymore. It'll just be set. And yeah, the goal is to be replaceable by design. You just want to scale Ethereum. And so to me, the main offering is there's been tons of research, tons of amazing development as well done by all kinds of other teams and by Ethereum core developers as well. But I'm frankly surprised that there's no differentiated offering like R1 that has come to the market or presented itself to the community yet, which is just unencumbered by some of the other things that maybe other layer 2 projects have, which might be commitments to private investors, their own third-party token, their own ideas about their own brand and what they'd want that to be. And the differentiated offering we see for R1 is really just the goal is scale Ethereum. The brand is transparently Ethereum, and there are no other commitments. And can we use that to maybe build in a different way and provide a differentiated offering as a layer 2 solution? Cool. So maybe to go a little bit more into some of the technical parts. So, or not even quite yet, but a little deeper. So yeah, what we know for sure is it's a new stage 2 rollup and that we are committed to using based sequencing. There's no token, no VCs. It's by and for the Ethereum community, and we're really hoping to honor that idea. Yeah, we have this plan to build on top of the great work from Tycho and the based rollup stack that they have. I think part of what's interesting about this idea coming to the world at this moment is maybe this would have been more difficult when there was still a lot of research to be done about how L2s might be made and accelerating snark development and a ton of we stand basically on the shoulders of giants and a ton of research and development that's been done. But now there's actually a lot of tools out there, and a lot of things have already come together to make it maybe possible that something that's truly just a community initiative can build, put all the pieces together and build a layer 2 solution that's somehow a bit different. So one thing we're going to get to at the end of this presentation, which I think will be most related to the idea of the sequencing calls, is we definitely want to target based preconfirmations, and I think we'll get into maybe the different flavors of these and what we're excited about here. And yeah, there are a few novel things about the R1 design that are already known to some degree, and that's this our plan to use this novel 2 out of 3 finality gadget, which we'll talk about in a second. And there was a lot of this work has come from great research that's been done by people at Nethermind, Ahmed, who's has been working with us, and also Vitalik, of course. So this is something new. And finally, we'd like to also contribute some sort of novel roll-up upgrade governance design. And ideally, that design is something that once we design it and we release it, could be something that other rollups could also opt into. So these are the things we're targeting. So as I said, things are not really set in stone yet. It's really an offering, an idea, see how we, the Ethereum community, can come together to build something this way, in this direction. And we're thinking of right now as phase 0 for R1. And in phase 0, we really are looking to actually nail down some of these concretely, some of like the plan of what our R1 would become. And instead of just setting that all in stone beforehand as some small group, we really want to do that along with the community. So to me, the really concrete things in this phase 0 are this finality gadget spec, but in my view, this is pretty much done. We'll talk about that in a moment. This governance gadget spec, what that might look like, how can you make it something maybe modularized enough so that other rollup projects could also opt in to utilize some of that infrastructure. A complete technical spec of all the details of what R1 rollup should look like, and finally some sort of concrete plan of how the development will be done to actually bring this thing into the world. During this phase 0, there's also, it's open for donations, and our goal is 1,000 ETH or more. If we don't make that, everyone can return their donations trustlessly using the Donate Smart contract. But if we do, then we can actually move forward with this concrete development plan. So we'll have these weekly open meetings. So everyone who's here, please look out for those. We'll probably start next week, where we try to move towards these goals as well in some asynchronous, communications and so forth. So I want to talk about so that's just the background, hopefully makes some sense. I want to talk a little bit about some of the novel things here, and we'll start with the governance gadget proposal. And this really is something where it's not set in stone at all. There's still a lot of room for feedback and learning more. But we wanted to ask this basic question, which is who should govern rollup upgrades? So I made this little picture here of a number of different stakeholders in the Ethereum community who might be potentially participants who would govern upgrades of a rollup like R1. So you have all of ETH, you have staked ETH, you have ETH that's bridged into this layer 2. You have people who were part of the group that donated the initial ETH that funds the project, or you have the dev team and some sort of guardian multisig. So these are the participants that might be able to govern. And so far, our design that we are leaning towards is something that looks like this. So we believe that all ETH holders, and maybe this design, I got some feedback, it's a little confusing. All ETH holders and staked ETH holders, notice, have no authority whatsoever. So they don't participate in any governance. Layer 1 simply, is what it is, and this is all about the layer 2 commitments that get checkpointed onto layer 1, so that simply don't need to govern over anything here. But the flow that we do see, all the other participants potentially do have some agency over seeing the rollups, the rollup upgrade. And I think the flow looks something like this. So the dev team might propose an upgrade. This upgrade requires the signature of the guardian multisig, and so this is like this is what without that, this upgrade will not go through. So this is just like a security measure. But note that this guardian multisig is not like the Security Council's multisigs that you have today on other layer 2s, which have like rushing upgrade authority and other sort of administrative powers. It's simply required that they approve the upgrade, but they can't push some arbitrary upgrade that they would like through without waiting for the exit window, etc. After that, there's definitely a 30-day minimum exit window, could even be longer, but that's at minimum. It's also needed in order to reach the stage 2 criteria. But the other two types of participants that we see as potentially having a role in governance only through veto power are two different subsets. One is the ETH donators, so everyone who donates to the donation contract, that can easily be tracked on chain and exactly their, weight. And you can create some criteria where that group, that committee can veto some upgrade that the Guardian has approved and that is waiting in the exit window. And then similarly, all the ETH that's bridged into the R1 L2 solution, those ETH holders could coordinate to reach a quorum enough of that ETH and also veto a certain upgrade. So the idea is that the people who actually funded the project or the people who are actually using the underlying system have a say in saying if they want any new changes to the rollup to actually be implemented. So this is the idea. One question would be, how can you modularize this? Or what are the actual abstractions, and like what do the smart contracts on L1 look like to make this system real and make it maybe reusable by others? But this is the current proposal for governance. And the goal is to minimize it. There are also interesting conversations going on about maybe making it not upgradable at all, in which case some of this would be less relevant. So I think there's still a lot of interesting ideas to hear from the community here. Okay, so let me see, I'm doing on time also. Yeah. So I think this is a really interesting part of the design. And again, this has been a lot of people, great researchers and contributors, Vitalik, etc., helping to create this design. So I'm really just relaying it more than one of the designers myself here. But I think it's a super interesting and clever way to try to reach fast finality and also have some safety as a ZK rollup. So yeah, let's see how I do here. The goal is to be able to, on a happy path, have very fast finality for the state transitions of this type of ZK rollup, or this rollup, R1. And one issue that I think is very important is that today ZK proving systems are still very young. We've had amazing acceleration, but there's still very much non-negligible fear of bugs in ZK proving systems. And so how can we try to still have reach the happy path of a getting very fast finality when the proof is actually constructed and verified on chain, you get finality, but also in the real world, in a world where ZK proving systems could have bugs and billions of dollars could be at risk, maybe have some trade-offs here to make it even more safe. So the idea is to use to get a heterogeneity of assumptions so that you might have a lot more safety in finalizing state transitions. So what you have here are basically two ZK systems. So it's two separate ZK proving systems, one that we're calling an optimistic ZK proving system and one that's like, let's say, traditional. And you also have the use of trusted execution environments. So these are your three systems, the trusted execution environment proving, and these two separate ZK proving systems. And two out of these three, you need the agreement of two out of these three systems for your rollup transitions to finalize. So the TEE system, because TEEs are, of course, they're just machines, right? They have some really nice properties, but they might be much cheaper to break. The one idea is also that the TEE system itself is a 2 out of 2 TEE system, so you can get different types of TEEs. So if there was some sort of zero-day attack on SGX or whatever it might be, TDX, this doesn't compromise outright the TEE system in this design. But yeah, that's what I want to say about TEEs. But I think the really interesting thing that took me a while to get myself is this idea that by having this one OP-ZK system and the traditional ZK system side by side, you should make it so that even if these two ZK proving systems shared a soundness bug, let's say, you still would also have to pwn the TEE in order to to get this 2 out of 3 and accept. Or you would have to find a soundness bug in one TEE system and a completeness bug in the other in order to get this 2 out of 3. And I'll explain a little bit more in a moment. But so the idea, let's just go from the happy path here. In the happiest path, a sequencer will, progress the rollup. Without going into too many details here, there's maybe the idea that a sequencer might place a bond. This is just so that when they progress the rollup and then provide their proof later, there's something at risk so that they actually have to provide this proof. If they don't, then someone after a certain time stamp, someone else could provide this proof on their behalf, and if it gets finalized, then they win the bond back. But if you actually finalize your state transition, then you get your bond back as a sequencer. So you place this bond, you transition the rollup to the new state S, and then finally you in the happy path, you would now present the proofs, which might be the agreement of these TEEs with this your state transition, as well as the ZK proof you constructed with some ZK EVM, let's say risk 0, whatever it may be. And if you provide these things and they agree, you get instant finality after these proofs land on the L1. So that's the happy path. Let's say on an unhappy path, maybe the TEEs are just dead, not alive, and there's liveness failure for the TEEs, or maybe they're doing something erroneous. This is where the OPZK system comes in. So if you don't have this agreement between the TEEs and the ZK proving system, then you have to wait we move into more like the way an optimistic rollup might be, where you actually have to wait for a 7-day window. And during this 7-day window, if nobody can provide a challenging proof for the ZK EVM, then eventually you can finalize. So I think what's interesting here is, again, if you had a soundness bug, even in both of these ZK systems, you actually would not be able to finalize your malicious state transition. And that's because in the OPZK system, well, it's a soundness bug, which means we can prove arbitrary statements. So here, you just need one honest actor in the OPZK system to reject this malicious S star, let's call it, and then this malicious S star will not finalize, unless you could also, let's say, I don't know, backdoor the TEEs as well, and then you would be able to, and have them agree with your initial S star malicious state transition, and then you would be able to finalize such a thing. So there you have the idea for the Finality gadget. I think this is really exciting work personally, so I'm quite excited about this, and might be relevant for when we finally get into more sequencing related topics. I just show this. There's an even more in-depth diagram from Ahmed from Nethermind, and some stuff that's interesting related to what we were talking about the governance gadget before is some of the upgrade conditions where potentially, if you look at these blue boxes on the bottom, you might be able to more quickly upgrade some faulty proving system by using what you learn through like the 2 out of 3 proving technique, so that you don't actually have to wait a long delay in this case, because you can be sure that there's some problem with X proving system, and that's the problematic one, while the other two are following things correctly. So yeah, feel free to look at these diagrams more in depth if you'd like. So now I think where we finally get to is R1 as a based sequenced rollup, and how can we provide a great experience for applications. And here I think preconfirmations will be very important and play a major part. So yeah, I think I'm going to pass it off to Junger for now to talk maybe about the different flavors of preconfirmations we might target. Potentially at the end, I might say a few comments or maybe thoughts and suggestions about preconfs. But yeah, Junger, if that sounds good. take it away.
Yeah, thanks for the whole presentation. So actually, at the base sequencing calls, we already covered a lot of things. So I don't want to I don't want to mention again all of them. So basically, I mean, from our point of view, Ethereum's own rollup should be base rollup because we have to use all of the modules of Ethereum, uh, like sequencing, like data, and in future execution. So there is a lot of improvements on the base sequencing part because thanks to Tycho, we have very mature base rollup stack. So it's going really well, and I really appreciated them to build that stuff. So yeah, the main difference of R1 from the other rollups will be Finality gadget, but the tech stack will be similar. So base preconfirmations are also a very important thing to solve economic problems of base rollup. I felt, I mean, there's a lot of thing on the economic side of base rollups. So yeah, from base preconfirmation side, there's also a lot of improvements on this side, like commit boost, fabric, uh, yeah, MEV commit. So we have very good tech stack right now. So there's a lot of research also. So it's still going on. We will utilize their research, and also we will contribute from the research perspective. So yeah, base rollups are a very efficient way to build a rollup. I mean, from alignment perspective also, and also provides, in a sense, synchronous composability. So that's possible. So yeah, that's my 2 cents. So
Cool. Yeah, I will mention a few more things here, and then I think we'll get to questions pretty early. And actually, this might help shape the conversation a good amount. Very excited to hear the kinds of questions people might have. Um, I think for me to zoom out on the pre-conf discussion for a second, um, I think again, what seems important about R1, and this is very much my opinion, not the opinion of R1 itself, is its differentiation. And I feel like the key of this differentiation comes actually from this ethos, not encumbered by other types of private investors, private commitments that it needs to make good on. It doesn't necessarily need to be an exponentially profitable company, and it doesn't have this kind of baggage. And so how can we maximally leverage that to have a differentiated offering that actually matters for users? That's cool from an ideological perspective, but is there something that actually, is there a path that affords, that maybe other projects might be more reticent to take or can't take, that actually ends up giving users a much better experience? And here is where I see this road to synchronous composability being really exciting for R1. I think maybe for other L2 projects, there might be much deeper set of trade-offs to like commit boldly towards just trying to create an architecture that fits that vision and that allows us to reach a synchronously composable Ethereum where you no longer have to fight tooth and nail against everyone for liquidity network effects on your rollup, but we can simply interoperate. I think this is a really exciting differentiation. I think there are also some other ones. You can think about censorship resistance and neutrality and things like this. But for me, I'm most excited around actually what are the core concrete benefits. If a user doesn't care about any of these ideological parts, they just want to know where they should build their application. Are there ways that R1 could be somewhere that other projects might not be, or get there faster? And so to me, yeah, I'm quite excited around the actual feature set, trying to accelerate towards a feature set that's not just parity with other kinds of rollups, let's say like single sequencer rollups. So you can already get parity by some of the designs, maybe even with like a whitelisted set of sequencers, um, in like a based sequence design. But you'll just get parity. You'll be able to offer pre-confirmations and not have this slowness that you have to deal with a based rollup where you must wait for the L1 block time. But you don't yet gain anything that you don't already have on other roll-up solutions. So to me, I'm really excited about things like L1 S load, L1 call, eventually with things like commit boost and Fabric getting more mature, actually being able to offer a user experience which is completely new, where you have this synchronous stitching, or maybe almost synchronous stitching if there's some step in between, that allows you to build applications actually in a way that you could not on, let's say, Base. Yeah, I think this is really the exciting part of the conversation. Maybe the questions can push us in the right direction to learn more about this part. But this is what we had. Thanks for listening, everybody. And we're really excited to get started with R1.
Amazing. Thank you so much for the presentation. If you have any questions, feel free to just unmute or ask in the chat or raise your hand. Orest.
Cassandra, yeah, first of all, thank you. Super interesting. I was wondering, you did mention that a combo of a soundness and a completeness bug be the dangerous one. Why would completeness be an issue for integrity?
So as far as I understand, maybe I can even try to go back. As far as I understand, the issue is that if so let's say the TEs are dead, right? So you can't use the TEs, they don't help. So you are able to, you find this soundness bug in ZK system 1, and you exploit it, and you try to prove state transition S star. Now, nothing happened with the TEs, so we go into the ZK optimistic proving system. If there's no bug in that system, you're fine, obviously. Let's say there is the same bug, and this is what I find quite interesting, is the idea that actually today, different ZK proving systems, they are different, but they're not that different. And so the idea that they might share the exact same soundness bug is actually not so unlikely. So if that's all you have the same soundness bug on the OP-ZK system, on the ZK2 system, that's not a problem. Because as long as you have one honest actor, right? A soundness bug implies you can prove anything, right? So one honest actor will show that, hey, there is actually this S star is not the only thing you can prove, and so it won't go through. And so that means the only way you could get through with these two systems is if you had the soundness bug in ZK system 1, and in ZK system 2, you somehow couldn't fail to prove anything for this state transition. And then you'd wait the 7 days, the clock would run out, and 2 out of 3 would. Does that make sense?
Yeah, it makes sense. Thank you. Interesting.
One question I have is on the donations. So there's this interesting mechanism whereby if you don't reach the 1,000 ETH, the funds are returned. Is the idea that R1 will only go through if you can raise the 1,000 ETH?
That is the idea, and the rationale for this was chosen, I believe, mainly for the idea that this is what we believe is like the absolute minimum today that might be needed to actually spin up this project in earnest. The main thing that was considered to try to find that like lower bar of what might be needed to actually make it worth develop this project and bring it into the world completed is things like infrastructure costs for proving, and what kind of scale would we like to target? How much infrastructure cost would that be for something like 6 to 12 months? And we arrived at 1,000 ETH as like some sort of lower bar. But this is definitely hand wavy math. But yeah, we believe that it maybe does a disservice to the 15 ETH that donates if that's all you get, and then you try to build something, with such a small amount of funding.
Yeah, I could add a few other points. I think the rationale is that we are just proposing a proposal to Ethereum community. So if Ethereum community don't want it, don't want to fund it, don't want to see it exist, there's no reason for us to work on that. So yeah, vote with your ETH.
Sasha from Lido is asking, is the idea that fees alone will make it sustainable after 6 to 12 months?
We have no idea.
Yeah.
Yeah.
No idea. I agree with that. I think one thing that's true is that the goal is certainly that eventually you reach something fully sustainable. So there is this idea that by 2030, either Ethereum has gotten to such a place that you don't even need L2s at all anymore for some reason, or that this thing, you know, by that moment would be fully sustainable. There's absolutely, you know, it's sustainable to sequence this yourself. You have a very, you know, heterogeneous group that's actually doing that, and you don't need some sort of dev team to have some funding stream in order to keep the project alive.
Yeah, just one thing here we're working on for Surge, and by design we'll go to R1 if R1 adopts Surge, is that we're working on like currently the base rollups that I know of, they don't incorporate the L1 fees into the L2 transaction fees. And this is something that we're looking into right now heavily. And we think that it is one of the preconditions to actually go to mainnet for Surge or for R1. Because if we want to showcase, like the rollups have been, like unless you have a certain volume on your rollup, then you are basically most likely subsidizing a lot of the cost for proposing, for proving, etc. And we don't want to showcase the tech in that way. We want to showcase the tech as pure as possible. And the way to do it is by showcasing the actual L2 fees that you need to pay to actually, then propose and prove on the L1. Obviously, this with low transaction volume, the L2 fees will be higher than you would normally see on other L2s. But as volume starts picking up, then you might see these transactions actually become cheaper and cheaper as they can share the proposing and proving fees that are carried on the L1. So yeah, it is an area that we're looking into, and it's a prerequisite for going to mainnet for us.
Got it. So no subsidies, and you want to be very organic. Makes sense. Orest, you have your hand up.
One more question for, I guess, maybe Ahmad. I'm looking at the updated diagram, and I had assumed, hearing Justin's intro with combining crypto economic security like AVS style as potentially an additional security security adding measure, which I've long been a fan of, but I don't see it here. Like in here, the bond
Yeah.
is just some sort of like a small bond that the block proposer adds in, right?
Yeah.
Is this like the target design, or have you thought about using ABS or restake for the
Actually, for composability, especially like for fast, like I can't say that we're gonna use the AVS or the solver model or crypto economic security for fast settlements. I don't think this is something that we're aiming for. But if you look at one of the, it's been like out for a while. I just shared an article by the Surge research and engineering team about how we can do fast L2 to L1 bridge outs without waiting for the proof to come in. And incorporating this with the other article that we have also for instant L1 to L2 messaging, you can get like same slot, bridge in, bridge out, and bridge in, transact, bridge out kind of behavior with the L2. So like this is something that also we are working on, and it is in the roadmap for Surge.
Yeah.
Florian from Linea has shared a link in the chat where he has basically estimates as to how much gas will cost if L2s are not subsidized. And that's in the context of the Linea blockchain, which may also become based in the future.
And also to add on this, like Ahmad, you were mentioning like you don't want to subsidize fees. So this is one first approach to take into account data availability. For the proving cost, there was discussion on how to estimate them, and I think it was there was some ideas presented also along this line in the previous call. So there is discussion on this. I'm happy to discuss this further whenever you want.
Yeah, I'll definitely look into this. I will also ask the team to look into this document. Thank you very much for sharing it. And we'll probably, if we have any questions or further collaborations, we'll probably reach out. We already have your guys' contacts. Yeah, awesome. Thank you very much.
Yeah, one thing I didn't mention about the costs and this idea of this minimum bar is, of course, there is also L1 gas costs as well, but I believe we think that the proving costs will be much larger multiple than the L1 gas costs.
Actually, in reality, with high transaction volumes, the actual cost comes from the on-chain verification of the proofs rather than coming from the proving cost off-chain. So yeah, like it all depends on the amount of volume that you have and how many times you are going to propose blocks and how many times you're going to prove them. So with that, like Tycho has been doing such amazing work with their code base, where they now have introduced with the new spec that is coming to mainnet in June or July. They introduced something called batching. So that now you can submit multiple blocks in a single batch, and then for this whole batch, you can verify a single proof on chain. This amounts for a huge amount of cost saving, because a single batch could have like hundreds of blocks, and you basically reduce the cost of the proof verification by that amount, like 1/100 if you for example put 100 blocks in a batch. So yeah, like it's the work that is being done here, especially by the Tycho team, for cost savings and for base rollups in general, is very impressive.
Just on the proving cost, I think the thing that could make things a lot simpler would be to manage to align the gas cost of the opcode to the actual cost of proving the opcode. So there is some research, I think there is an EP about this, to review the pricing of the opcode to better reflect the proving cost of them, and it would make this pricing and like not subsidizing the transaction a lot easier.
Yeah, so there is the concept, like I think that the one that have introduced this concept before was ZK Sync, when they introduced this concept called ZK Gas. And I think this ZK Gas concept is very interesting, where you go and profile all the precompiles and all the opcodes that the EVM supports, and then once you have that, you can profile that how many ZK cycles it requires to actually prove each opcode in each precompile, and then you can price the transactions based on how much ZK gas it is consuming. So this is for off-chain proving costs, right? And like, so there is these ZK killers that we know about and we heard about from the ZK. What was it called? ZK proofs call, and we know about the ZK killers. But yeah, like what we want to accomplish is actually to profile every single opcode and every single precompile. I don't know if there is someone who's doing this effort, because Nethermind is actually interested in this, applying for a grant for something like this, but I don't know if someone else is already doing it. Obviously, like we'll reach out to the EF and ask these questions and see if someone is already doing this effort. There is no need to like replicate it. But yeah, like it is something that we're looking into and very interested to look into further.
So there is Evo in Linea with was working a bit on this. I just shared the EIP in the chat. It's not exhaustive, so maybe you want to do some larger efforts, but definitely there is some work that has been done, so it's worth discussing this.
I remembered one thing I didn't mention, so that just want to mention briefly, which is I made no mention of native rollups and the native precompile. I think this is something that R1 is also deeply interested in. It's only not mentioned because this is something that does not exist yet today. And so it's also somewhat path dependent on R1's approach to upgrades. Would it be something you launch completely separately, or are there these long delayed upgrade paths that actually exist? And if so, I think we would be interested in this precompile, somewhat tangential to the most recent conversation, but maybe matters a bit in terms of how you compress L1 costs.
I mean, the execute precompile might be helpful to collapse all of the complexity around the two TEs and the two proof systems into just the one precompile. Makes sense.
Yeah, totally.
One of the hidden costs of running a rollup is all of the integration costs with some of the tooling like Etherscan or Chainlink, which cost millions of dollars, and 1,000 ETH is not going to cut it. So is the idea to have pro bono integrations with Etherscan and other providers?
I mean, they always can offer their services if they are like want to align with the Ethereum and with the community, etc. We're not going to be like, no, we don't want your help. Of course, any help is appreciated. Anyone can contribute. But there is like, so for example, what we're aiming to do is we're aiming to do like an L1 S load or an L1 call mechanism where you can actually, if you want to call like a Chainlink Oracle, you can just call the L1 Chainlink Oracle. Yes, there might be some slight delay in the result that you get from the L1 Chainlink Oracle, but it's still something that you can use, and it could be viable. Yeah, and like, but so this is might be like our way of like the cheap man's Oracle, right? To do composability with the L1, and then we can just rely on the L1 for most of the tooling. But yeah, like obviously it's not like a sustained solution for all the or like a complete solution for all the tooling that might be required. And of course, we rely on the community support to get this done.
Absolutely, and this is also where I see that fork in the road of the trajectories of how this project is being built, and why I was mentioning for a while having this actual differentiated offering for applications and users. Why it would be so exciting if today we could have like fully real-time proving already. Then I would see R1 as very likely would want to launch with like synchronous composability from day one, where basically the idea is, right, instead of that there's actually a reason that there's a lot of network effects around this execution environment, and then a lot of that tooling starts to come as well because of these network effects, and that this is ultimately drawn, that drawing in of these different participants is ultimately because of this differentiated, this better tech stack that we can be the first one to be towards. So to me, I feel like this is, we certainly can't compete on having the biggest coffers with other L2s in order to have lots of money to give out grants and all kinds of tooling and so forth. But maybe because of the difference of sort of how it was built and who the stakeholders are, we can have a faster path towards a user experience that then actually creates a lot of network effect and brings the tooling naturally.
Junger,
One thing that
go ahead.
Sorry, one thing that I'd like to note is that the R1 itself and Surge itself do not have a tech stack. So what we are depending on is the generous open source project of Tycho. And what Surge does is that adds these extra features, extra boosters to the already existing tech stack that is offered from Tyco. And what R1 comes in and adds the community governance and the community effort around to push then this rollup project forward. So like if it weren't for like the Tyco team and their earlier work, none of this would have been possible. And like so yeah, very grateful for the Tyco team for their open source work and over the years, honestly.
So Junger in the chat made an interesting comment. He said that when R1 was announced, there were many offers from oracles, big DeFi apps, and explorers to make integrations for free. So it looks like the expectation is to not pay anything for all of these critical integrations, which is fantastic. Talking about Tyco, I believe that there is a base rollup summit which is being organized, and Joaquin has a message for us on that event.
Yeah, thanks, Justin. Hey guys, it's Joaquin here, CEO at Tyco. By the way, thanks everyone guys for the presentation, and thanks for the kind words for Tyco. We really appreciate it. I'll be quite quick on my end. So we just wanted to flag that exactly, right? We're organizing a follow-up to the base rollup summit, this time during HCC in Cairns. It's scheduled for July 1st. And for the ones that don't know about it, it's like an extension for these calls, which are really good, insightful, but instead of online, we make it IRL. We realized there was no real gathering dedicated to this. So that's the intention of this event. It's on similar topics to the sequencing calls around sequencing, pre-confirmations, base rollups, and some other Ethereum hot topics. Last one was in SF a few months ago, was really, really good. So if you'll be around in July, I guess most of you will be there. Well, first of all, feel free to join. It's of course free, but limited in space. But if you like to get more involved, we are very open to suggestions on topics, formats, edge cases, like whatever. It's a really nice opportunity to bring all these conversations to real life. And we really try to make it meaningful for everyone's time and for Ethereum overall. It's not only about the talks, but also about getting together overall. Also want to share, we have a short sponsors deck for anyone interested in supporting the event. Some tiers include speaking slots. Of course, needless to say, we are being very thoughtful about fit to keep every session high value. But yeah, it's nothing crazy in terms of cost, but it just help us, make it happen and hopefully run more of this, because it's quite an expensive thing to do, to be honest. So yeah, just to finalize it, if you want more information about the last one and this next one, we've got a web page for this Luma page, and all the links are ready to share. Actually, I'm going to share them here in the call now. Not sure if people outside can access them, probably not. So perhaps for whoever listens to this call later, you can just maybe ping the Tyco X account if easier. And yeah, and thanks to Drew and the Fabric team. They're helping a lot, shape the whole thing, get speakers on board, and make sure it runs smoothly. Yeah, that's it. Back to you, Justin.
Thank you, Joaquin. So we're at the hour. This wraps up sequencing call number 18. Thank you so much to Ariel, Jajun, Junger, and Ahmad. First of all, for presenting the proposal, but also for sharing their thoughts today. This is the end of the public segment of the call, and we'll now open it up for off-the-record conversations.